Welcome everyone, my name is Mr. McGregor, and in this video we're going to be looking at calculating different types of energy. By the end of this video, you'll be able to define the term gravitational potential energy and use the formula to calculate gravitational potential energy, and you'll be able to define the term kinetic energy and use the formula to calculate kinetic energy. So the first equation is for kinetic energy. EK stands for energy kinetic, and the equation says that that is equal to a half times the mass m multiplied by the speed v squared. So let us look at an example. Let's say the green car is travelling at 14 meters per second, about 50 k's an hour, and the red car is travelling at twice that speed, 28 meters per second. Let's say they both have the same mass, 1200 kilograms, and obviously they're travelling at the two speeds, 14 meters per second and 28 meters per second. Let's take our kinetic energy equation. EK is equal to half times m times v squared, and we plug in the values, a half times 1200 times 14 squared. Plug that into your calculator, and you should get an answer of 117,600 joules. Let's look at the red car. Again, use the same equation, plug in the values there, and we see we get 470,400 joules. And one thing to note here is that even though our speed has doubled, it's gone from 14 up to 28, our kinetic energy has more than doubled. It's gone from 117,000 to 470,000. That more than doubling effect happens because of the square in that equation. When we double the speed, our kinetic energy goes up by 4. Now let's look at gravitational potential energy. The formula says that EP, standing for the energy potential, is equal to the mass multiplied by the strength of gravity G multiplied by the height H. And we note again that the energy is measured in joules, mass is in kilograms, G is the strength of gravity, and here on Earth that is 10 once again, and the height h is in meters. So let's look at an example with this equation. Here we see a classic roadrunner trap which Coyote has set up. He's raised a 120 kilogram anvil 5 meters above the road surface in preparation for Roadrunner to come past. The question is, what is the gravitational potential energy of the anvil? So we use our equation, EP equals m times g times h. Its mass is 120, multiplied by 10, because it's here on Earth, multiplied by the vertical height, which is 5. Plug that into your calculator, and you get 6,000 joules. Now what happens in this case if we double the height? So instead of 5 meters, it's 10 meters. Well, we simply plug in those values, 120 times 10 times 10, and we see here the energy has doubled. It's now 12,000 joules instead of 6,000. And the reason that has doubled is because there is no square in this equation. So it's a little bit different from the kinetic energy one in that regard. So now you know how to use the kinetic energy equation to calculate kinetic energy, and how to use the gravitational potential equation to calculate gravitational potential energy. Thanks for watching.